All right, for this, we're going to focus in on building a linear regression based off of some data. We're going to do all of this with Desmos. So we'll start with the scatter plot, go to linear regression, and then look at the correlation coefficient. So first things first, let's go ahead and go to Desmos. You'll notice what I've done, I've started the table. In order to get a table, you go to add item, and then all you need to do is enter the table and one will show up for you to start plugging your data in. For the purposes of this video, I just went ahead and started the table. You're going to just simply go 1, 850, start plugging in that data, 2, 1200, and 3, 3,567. Now, as we're looking at this data, you're going to notice in the home screen that, hey, this does not pop up. And that's because a lot of this information in the data table is way off of there. And what we can do is we can, if you've got touchscreen, start backing out. But you notice it's going to take a long time to get to those values. In fact, the first one is right there at 1200. We can continue to back out if we want to, or we can come over here to the wrench, which I like, and we can actually start plugging some things in. So the lowest X in our table is 1. So I'm just going to simply put that here. The highest X in our table is 7. Then I'm going to go to the Y's, and I'm going to plug in the lowest Y value, which is 850. And the highest Y value in our table is 23,486. And what you'll notice is that data should start to show up. Now from here, we can use our touch screens or whatever you want. You can zoom in and zoom out given the negative and plus sign over here on the far right, but you can zoom out and it does make our graphs a little bit easier. Now, if you were to look at this data, you can see that it probably has a linear regression that can model it. And we can assume that maybe, hey, there's a line that can be modeled through this here. Now, when we make the equation of a line, we have to remember that the line is y equals to mx plus b. So that's what we're going to be looking for. But we have to reference this data over here. So when we do that, we're simply going to type y1 and then mx1 plus b. And I'm using ones because the ones are what's showing up at the table. Now, the other thing that we also have to do is we have to change this symbol from equals. We're going to change it to approximate right there when we type things in. You can find that button right above the tab button on the left-hand side of your keyboard. So let's go ahead and type that in. So I'm going to type in Y1, shift. I'm going to go after the button right above the tab sign on the left, and then I'm going to type MX1 plus B. Now, the beautiful thing is you can see the approximate line that it is giving me is slightly different than the one that I had guessed, but that's a pretty good guess for myself. Now what we're going to do is we're going to fill in the equation of line so we can make some calculations. Now it says y1 is approximate mx1 plus b. When we write the equation of the line, we want to always add our slope and our y-intercept, and you can actually see those values right here. M is 3,803 and B is negative 6,162. So I'm just going to simply type in that information. I'm going to use f of x equals to 3,803.75 x minus 6,162.29. And then what I'm going to do is I'm going to turn off the statistical one, which is in cell 2, just to see if they overlap each other perfectly and check it out. It looks like we're doing a pretty good job. It's always good to check our work. Now, once we have that in here, we have the equation of line, and we can actually begin to make, we can go ahead and make predictions outside of the data, which is called extrapolation. And we can also make predictions inside the data or interpolate within the data. So the last thing we wanted to do based off of our questioning is we had to create a scatter plot, which we've done. We have now created a linear regression. We can write that down if we needed to. We're going to find what is the correlation coefficient and what does it indicate about the line of the best fit. Okay, so let's go find that. The correlation coefficient is a statistical piece of data that tells us if it is actually a good fit or a good model. You can see that right here, that R value, and that is the correlation coefficient. Okay, and you'll notice that it is 0.961. So these values go -1 to 1. And what this tells us is that this is a strong positive relationship. And that is telling us that it is since it is a strong positive relationship, that is actually telling us that this is a great model based off of the data. So 0.961 is telling us strong positive relationship, and it is a strong data. How do we know it's strong positive? Anything between 0.7 and 1 tells us that it is strong positive. Anything below that starts to get into whether or not it is moderate relationship or even a weak relationship. A closer we get to 0 is weak to no relationship. Okay, so 0 is a weak to no relationship. All right, well, I hope that helps you out with coming up with a line of best fit on Desmos based off some stats, and then also understanding where to look for the correlation coefficient on Desmos.